aircraft, mostly military, are supersonic. They can fly faster than sound. When they do, they produce a sonic boom. We hear this boom before we hear the noise of the airplane. What makes this sonic boom? And why do we hear the sound of the airplane only afterwards? Sound expands in a sphere. The sound source produces vibrations which travel in all directions as waves of compressed air. Though the sound waves move in 3 dimensions, we can make it clearer if we show them in 2. A white circle will represent a single wave of compressed air. Now here is the sound source, and here is the person who hears the sound. First, the situation where the sound source doesn't move. The compressed waves of air travel in regular succession, equally spaced. The distance between 2 compressions is called a wavelength, represented by this symbol, the Greek letter lambda. This has shown how the compressions expand when the sound source stays in place. But what happens when the sound source is moving? We'll represent the speed of sound by the letter C. V stands for the speed of the sound source. Let's see what happens when the speed of the sound source is half the speed of sound. V equals 1/2 C. When the sound source moves, the waves of compressed air in front of the sound source are closer together. This means that the wavelength here is shorter than the wavelength of a stationary sound source. And behind, the wavelength is longer. Now let's look at the picture when the sound source moves at the same speed as sound, when V equals C. The compressed waves accumulate. They will all reach the observer at the same time. He hears a loud boom. This time, the sound source will move faster than sound, at supersonic speed. For our example, we will have it move twice as fast. Let's say that the observer is on the ground below an aircraft. The wave compressions now form a cone. This is easier to see when we begin to draw in more of the innumerable sound waves that are actually generated. The more waves, the more obvious the cone. On the surface of the cone, the compressions are very close to each other. They combine to form a percussion wave, which a person perceives as a very sharp booming sound. An airplane flying at supersonic speed produces a conic percussion wave, which follows behind it. Wherever the percussion wave hits the ground, the supersonic boom can be heard. Now, at the house on the river. Now, at the house near the woods. The percussion wave produces more than just a loud, startling sound. It can break windows. So to avoid damage and annoyance, aircraft aren't allowed to fly low at supersonic speeds over settled areas.